Good day, students. My name is Mrs. Oludipe Odubolanle Oluremi. I am your mathematics teacher for this session, and the topic to be treated is change of subjects of formula, lesson objective. At the end of the lesson, students will be able to A. Recall the definition of simple equation and solve questions on it. B. Explain the steps involved and solve the change of subjects of formula in a given question. Enjoy the lesson. Simple equation. Recall that a simple equation may be seen as a mathematical statement that contains only one variable and the highest power of the variable is 1. To solve a simple equation, we collect the like terms and add or subtract where necessary, and then divide both sides by the coefficients of the unknown or variables in order to get its value. Simple equations are the conditions on the variables. An equation tells that the expression on the left side is equal to that on the right side. The expression on the left side of equal to is the LHS, and the one on the right side is the RHS. Example 1. Solve the equation 4x plus 3 is equal to 15. Solution. 4x plus 3 is equal to 15. Collect the like terms. 4x is equal to 15 minus 3. 4x is equal to 12. Divide both sides by 4. 4x over 4 is equal to 12 over 4. Therefore, x is equal to 3. Example 2. If 6 minus 2n is equal to 9 plus n, find the value of n. Solution. 6 is equal to 9 plus n. Collect the like terms. Minus 2n minus n is equal to 9 minus 6. Minus 3n is equal to 3. Divide both sides by minus 3. Minus 3n over minus 3 is equal to 3 over minus 3. Therefore, n is equal to minus 1. Let's look at change of subject of formula. The term change of subject of formula implies transformation of a given formula to make another quantity, usually a letter, the subject of the equation. Whenever the subject of a formula is to be changed, the intention is to make the value becoming the subject stand alone and remain on the left hand of the expression. The methods used to effect this change may be any basic mathematical principles like multiplication, addition, subtraction, division, finding square roots, squares, and so on. Whatever operation that is used to perform the change must be applied to both sides of the expression or formula. Let's go on a short break. You are welcome back. Notes: some basic guides in solving any given question are: 1. Remove square root if present. 2. Clear fractions, clear brackets if they exist. 3. Collect like terms together involving the required subjects. 4. If necessary, factorize the term on each side of the equation. 5. Isolate the required subjects, usually by division by a common factor. Also, note that the stated guides are no restrict rules to be followed when solving any problem under this topic. Cases involving indices or powers. Example 1. Make U the subject of the formula v square is equal to u square plus 2as. Solution: v square is equal to u square plus 2as. Rearrange to bring the subject to the left-hand side. We have u square plus 2as is equal to v square. Subtract 2as from both sides. U square plus 2as minus 2as is equal to v square minus 2as. U square is equal to v square minus 2as. Since u is squared, we find the square root of both sides. Square root of u square is equal to square root of v square minus 2as. Therefore, u is equal to plus or minus square root of v square minus 2as. Example 2. Waec 2014, question 14. Make U the subject of the formula. E is equal to m over 2g bracket v square minus u square. Solution: E is equal to m over 2g bracket v square minus u square. Cross multiply the equation. 2ge is equal to m bracket v square minus u square. Open the brackets. 2ge is equal to mv square minus mu square. Bring mu square to the left hand side. Mu square is equal to mv square minus 2ge. Divide both sides by m. Mu square over m is equal to mv square over m minus 2ge over m. U square is equal to v square minus 2ge over m. Take the square root of both sides. Therefore, u is equal to plus or minus square root of v square minus 2ge all over m. Meet you after the time out. Welcome back. Now, let's solve cases involving non-indices, that is, no power. Example 1. Neco, 2013, question 9. Make T the subject of the formula P is equal to bracket T minus 1 AX minus AT. A. P minus AX over AX minus A. B. P plus AX over AX minus A. C. P plus AX. D. P plus AT over AT. Solution. P is equal to bracket T minus 1 AX minus AT. Open up the brackets. P is equal to AXT minus AX minus AT. Collect the like terms in T. P plus AX is equal to AXT minus AT. Factor out T at right hand side. P plus AX is equal to T bracket AX minus A. Divide both sides by AX minus A. P plus AX over AX minus A is equal to T bracket AX minus A over AX minus A. AX minus A divides AX minus A on the right hand side. Therefore, P plus AX over AX minus A is equal to T. The key is B. Example 2. Waec 2012 question 11. Make P the subject of the relation Q is equal to 3P over R plus X over 2. A. P is equal to 2Q minus RX over 6. B. P is equal to 2QR minus XR minus 3. C. P is equal to 2QR minus R over 6. D. P is equal to 2QR minus RX over 6. Solution. Q is equal to 3P over R plus X over 2. Find the LCM of R and 2 and solve. Q is equal to 2 brackets 3P plus R bracket X over 2R. Q is equal to 6P plus RX over 2R. Cross multiply the equation. 6P plus Rx is equal to 2QR. Collect the like terms in R together. 6P is equal to 2QR minus Rx. Divide both sides by 6. 6P over 6 is equal to 2QR minus Rx over 6. Therefore, P is equal to 2QR minus Rx over 6. The key is D. References: check Waec 2009 question 29, 2017 question 41. Thank you for listening. Bye for now.